Live yet. Okay, we are live. Great. Hello,
Yes.
everyone. Welcome to this week's PUG Live. Today, we are going to talk about Azure Active Directory. Why do we OAuth the way we do? I'm Omkar here. Uh, I'm a cloud consultant. I work with Rapid Circle. If you have attended previous PUG Live sessions, you know my intro. So I'm not going to spend much time on my introduction. But the topic that we are going to discuss today is very close to my heart because I've been spending time with OAuth flows for quite some time. So I'll delve into those details as well. But before we begin, a disclaimer. I'm streaming this from my home and internet connectivity can be dicey at times. So if at all I do get disconnected, please forgive me. I'll be back in a couple of minutes. I do have a backup connection. The failover just might take a few seconds and that's basically what there might be that delay. Yeah, so with that, coming back to my OAuth journey. So basically, I personally started working with OAuth due to Twitter. Around 2010, I was working at a startup that was building a scoring system, a social scoring system. If you have heard of Cloud, it was something very similar. And it used your Twitter profile, the kind of followers you have, the kind of followers your followers have, to understand what kind of social score you should be assigned. And this mechanism required users to log in with their Twitter IDs, and that is where I got introduced to OAuth, and I found it really fascinating. Um, and moving from there, I started working with enterprise solutions, and there's huge need for single sign-on all around. And that's where my engagements with OAuth carried on. And I'm very sure most of you working with enterprise solutions have worked with OAuth, are aware of some of the basics or aware of how it functions. So today what we are going to do is most of us have worked with Azure Active Directory. Uh, we have interfaced with Active Directory using most of the libraries that Microsoft has provided. And Microsoft has been of great help over here uh, in abstracting out the complexities, making the developer's life easy by making sure that you can engage you can engage with your application and integrate these authorization flows and allow users to sign in with Active Directory very easily. But what happens eventually is that not knowing the details of what's under the hood sometimes puts you in a tough spot. So we are going to try and understand what exactly runs under the hood when these Azure Active Directory auth flows function. So that is what basically our agenda is. It's very simple. It's why do we use OAuth? What does it do? And how does it work? That is what we are going to do today. Yeah. So with that, let's get started with our topic. So let's first demystify two of these terms, authentication and authorization. We are going to use them a lot. So yeah, I find it useful that we make sure that the meaning of both these terms is well established. So authentication is basically proving your identity, proving who you are. This can be done using login forms. This can be done using cookies, certificates, even HTTP access tokens, if you're thinking in advanced terms. Authorization, on the other hand, is where you understand, I know who you are, but I, I want to know what you're capable of doing. Are you able to read this mailbox? Are you able to create security groups in Active Directory? Are you able to read all contacts? Or when you log into Facebook, for example, to give a more generic case, when you log into Facebook, you see a list of people in your friend list. And do you see everybody on Facebook in there? No. So Facebook understands whose profiles you are authorized to look at. So that's where authorization comes into play. So it's important to understand these two terms in order to really understand how OAuth functions. So let's start with the why. Why are we using OAuth? So if you have attended any previous sessions, you know I like to put a solution in between. So it would always be good to have a solution in context and then understand what's the what is it that we are trying to solve? What is the problem statement and what is it that we are trying to solve? So the solution that we're looking at over here is we're building an app called Virtual Cheers for our organization. And what we intend to do is we intend to allow organizational users, basically employees in the organization, to log in to the Virtual Cheers app. What this app is going to do is it's COVID times right now. We just want to make sure that people appreciate each other a bit more. Everybody's going through stressful times at times if your team is working from home and all. So with this app, we basically want to improve engagement between employees. So what the Virtual Cheers app should be able to do is it should be able to allow your employee to log into this app, look for other employees and send them some cheers, appreciate them that, hey, you helped me out with XYZ. Thank you, so and so. So to do that, the app is going to need some information. It's going to need information if the user is the user logging in is really an employee. Sorry. So it's going to need to know that. It might even need to know the list of employees in the whole organization. And we might also want to say send notifications to teams when these cheers are being sent so that the cheers are visible to everyone on a company group, etc. So those could be the integrations that we implement. But how would we implement something like this? If a solution like this is supposed to be implemented, how do we go about it? So first question, how do I log into Virtual Cheers? So we basically allow users to enter their organizational credentials onto the Virtual Cheers app. Just put in your username and password, log in. We use the username and password in the Virtual Cheers app to carry on the future, carry on the further functionality. Or we use something slightly more advanced, something like a basic authentication HTTP header. So for those of you who are not aware of what uh, basic authentication HTTP header looks like. So it's basically a username and password separated by a colon and encoded into base 64. Now base 64 is reversible. It's not secure. It might look secure, but it certainly isn't. So do you allow your users to do that? So basically your login screen looks something like this. You go to virtualcheers.com and you're prompted that put in your company credentials, your username and password. And there, of course, some of your employees might be concerned that, hey, I'm putting my username and password. So to assure them that what your app is going to do, you provide that, yeah, we are only going to get your company contacts and we will not read your emails. There's a pinky promise over there and you go ahead and log in. But can this be trusted? Does this really work? So the problem is that how does the user trust Virtual Cheers with their password? Really, how do you ensure that the advertised scope is respected? It does say it's not going to read my emails, but what if it does? And especially if the Virtual Cheers app is going to be built by a third party and not by someone within your organization, there's a lot more reasons to not trust that application. So how do you handle this? Even culturally, it's not a good practice to make your users enter their credentials on domain names or interfaces, user interfaces that are not controlled by you. So that's yeah, if you're working with an organization that has gone through ISO compliances or so, I'm very sure you have gone through phishing trainings or something like that. So all of those are targeted to ensure that your employees do not use these credentials uh, on any interface, any domain name that does not belong to your company. Yeah. So to handle this, OAuth comes into picture. Now, OAuth 1 solved this, okay? But it had its own quirks, and we're not going to spend time over there. It's been a while since it's actually 8 years this month. October 2012 is when the OAuth 2.0 RFC was released, and so we're going to focus on that. So with OAuth 2.0, we are basically able to solve this problem. It's an authorization framework that enables third-party applications to obtain limited access to an HTTP service. That is what it aims to do. So that's the why. That is why we are using OAuth. That's the reason why we are using OAuth. I hope that message is clear now. Next, we move on to the what. So what does it do? Let's start over virtual chairs with OAuth. If we were to build virtual chairs with OAuth, what would we do? So you go to the virtualchairs.com homepage, and that's where you will see just a button, login with company ID. Yeah, you, you, you all must be very familiar with this flow, but we are going to go into the details of what exactly is happening here in the backend as well. You click on that button, and what's going to happen is you get redirected to the Azure Active Directory login page. You see there, login.microsoft.com. Yeah. So this is where your employees can establish trust. They can say that, yes, I can provide my username and password over here. This is a trusted authority. This is where I normally log in, right? You log in, and here you see the scope. So the scope being advertised on virtualchairs.com is meaningless, because there is no authority that can ensure that virtual chairs respects that scope. The scope being advertised over here is something that will always be respected, because this is something that Microsoft is going to enforce, right? So it's going to say that virtual chairs will be able to read your company contacts. It's going to read your company profile. I have tried to be a bit explicit over here. What will virtual chairs not be able to do? Not all uh, authorization servers uh, provide this sort of a message, but I'm just trying to make this explicit. I've seen that Twitter does something similar where it says that, hey, this is not going to be able to do XYZ. And this app is not going to send tweets while you're offline. This is the message that Twitter sends, for example. So this is based on how the authorization server implements it. And we are going to go through the details and terminologies of authorization server and everything a bit later as well. I just thought it might be good to give you a heads up. So you see this good prompt over here. Now you know that, okay, you can trust the scope. I'm fine with this. The app certainly needs to read my company profile and certainly needs to read my company contacts. So you click on accept or authorize, and there you start being redirected. Now this happens really fast. Those who have worked with single sign-on solutions with OAuth again are familiar with the redirect URL that we are showing over here. And this is basically, there's a code present in the URL, and that's how that, and then you suddenly come to the home page and you're logged in. You can see the actual interface of the application and it identifies you, and you can then send cheers from there to your colleagues and so on, right? That is how it functions. So if you have even not developed an application like this, you might have used an application that has had a similar flow. So that was the what. What is it doing? Now we're going to spend a lot of time on the hows. Okay, and this is the most important part of our session today. So in this section, what we are going to do is we are going to understand some basic concepts. We are going to go through the authorization flows, and we are going to go through some demos. Okay, so let's proceed. So establish trust. So first thing that you have to do if you're going to implement a solution like this is you have to establish trust with the authorization server. So there's a client ID and a client secret pair that is recorded with the authorization server, in this case Azure AD. Now mind you, I'm using the term Azure AD, but Microsoft has rebranded it as Microsoft Identity Platform. I am habitual to using this term, so I'm going to go ahead and do that, take liberty to do that today. But please be aware that the terminology henceforth in further documentation would be Microsoft Identity Server. So Azure AD developer is Microsoft Identity Platform. Sorry, Microsoft Identity Platform. Yeah. So yeah, but let's just go ahead with this. So with Azure AD, you're basically doing client ID and recording your client ID and client secret. In our solution, we have a client for virtual chairs and we have the resource server, which is the virtual chairs API. So what we are saying is that virtual chairs has a a web app, a front end that could be powered by Angular or React JS, basically a single page application. And there is a virtual cheers API as well. So there's two clients that we are using over here. So let's go again, reiterate through this and understand what exactly is happening. And we are going to go through the demos as well. It's not just slides, but just let's be patient. Let's make sure we are thorough with this. So when you go to this, go to the login company ID, you go to virtual cheers and you see login with company ID and you click on it. The first thing that happens is you are redirected to the authorized page. And in the authorized page, what we say is these are the this is the payload basically in the query of that URL, where we provide the response type that we want. There's a client ID, there's a scope that we want, there's a state mentioned over there. So this basically informs Microsoft that, okay, this is the client that is making this call. This is the scope that the client wants. And the state is basically added to make sure that the client always initializes this flow. So you'll understand the state a little bit better when we go to the next steps. So that is where Microsoft provides this nice user interface where you provide your company details, your company credentials, and it gives you this nice UI again with the advertised scope. And there's a callback. So you go back to the virtual cheers app with the code. And this time you have that code with you. So you requested for a code, that code is there with you, and the state is something that you have received. So now the app knows exactly this is the state of the user. This was the state of the user when he went, and that same state ID is coming back. So if you want to have your user interface reflect some update some of its own state, so you really know that this is the same user that came back because the user has exited your domain. You might lose some state, so you can just use this key to map the state over there. It's just to make sure the user experience is good. And then further, you make a backend call to fetch the token. So in the backend call, there's grant type code, there's client ID, client secret, and the code itself. And in exchange of this, the virtual cheers app is going to get this token. So the token looks something like a token type bearer, expires in how many seconds, the access token and the refresh token if required. By the way, Mayur, I'm getting a notification that I have bad network quality. Am I still clearly audible and is my screen visible?
Perfect. You're perfect.
Okay. Okay. Great. Great. So this is still on a very high level. I've still abstracted out a few parameters in here. This is still high level flow that we have looked at. So there's even for instance, there's the state parameter can also be passed over here, and Microsoft does require that. So we're going to look at that in the demo. But how does this flow really work? We're again going to try and visualize this. So we have the authorization server. We have the resource server, which is api.virtualcheers.com. In this case, the client is virtualcheers.com, where the SPA or single page application is hosted. Both of them establish trust with the authorization server. They both have their client ID, client secret registered over there. Then you have a resource owner, maybe Sanket comes up and he says, I intend to consume this service. He gets redirected to the authorization server, which in this case is login.microsoft.com. The basically there's consent being asked. Consent is authorized and authorization code is provided to virtualcheers.com. So that's on the domain name. That's basically a redirect URL that is already registered with Microsoft. And virtual cheers can now use that code and its client credentials to get the token. So that's where the token is received. It can then use that access token to access resources at api.virtualcheers.com. Okay. So you're just looking at accessing resources from virtualcheers.com, but this same could be applied to graph.com. Any other resource that even Microsoft provides.
Omkar, you may want to
Yeah.
turn off the video because your audio is getting choppy now.
Okay. I have turned off my video.
Yep.
Let's hope that this works better. Okay. So I hope things are clear over here, and I'm sure there must be questions coming in, and you can keep sending in your questions. I'm going to address them in between my slides. But we are going to go through these details again. Now you'll notice that I'm going to reiterate through these flows because this flow is crucial for understanding of OAuth. Okay. So what we are going to do is we are going to go to the demo. So let's see how the auth code flow really works in a real demo. So what I've done over here is I have a HTTP server. I have some static files created. This is sandbox code that I've tried to create last weekend. Basically, I thought it would be good to have a sandbox where we can experiment with these flows. So what we are going to do is we're going to host this sandbox code on a simple HTTP server. We are not going to use any fancy backend. We are not going to use any fancy libraries. All of the sandbox code is basically written in pure JavaScript or PowerShell to make it readable. So we didn't want any C# backend or anything that requires extra dependencies. We wanted to keep this as simple as possible. So what we are going to do is we are going to take a look at auth code. In this, we are going to, before we go to this code, let's actually take a look at the Active Directory. So what I've done here is in the Active Directory, I have two apps already registered. Ignore the other two. I've been testing things as well. But these two apps are something that I've created. I've created the Cheers API. So this is the resource server that we are going to use. And what this app is doing is it's exposing an API with the scope cheers.send. Now this could be any scope. You could have your API exposing any scope. It could be user.admin.all or user.read, any of that. For now, I have created a scope called cheers.send. And that is all. That is all that is over here. I have the client ID, client secret created as well. We're going to use that, but that's for later, not for this flow. This is just the uh, uh, client secret for Cheers API. And what I have done is I have registered also Cheers web client, and there's the application ID for that. There's a secret for it as well, and there's not much over here. It's pretty much empty. So I didn't want to keep copying client IDs and secrets over and over. So I've just taken the liberty to create it before this call, before this session. But um, it's this process is as easy as going ahead and creating an app registration. There's ample documentation that Microsoft has provided about how to reach here, if at all you have doubts. But I'm very sure most of you must be aware of this. So with that being said, the client ID over here is important. I'm just going to copy this for the sake of simplicity. And we are going to come here. We are going to come to the login page. In the login HTML, what we are doing is we are using the tenant ID, which is also present over here. And we are using the client ID. And we are saying response type is code. There can be different response types. We are going to explore some of them a bit further. Then there is the response mode. Then there is a redirect URI and there is a scope. In the scope, you will notice we have entered the same scope that is exposed by our Cheers API app. Okay. Now, you'll see over here, there's response mode as well. This is the reason why I said that I've simplified the slide deck because there's complexities in here. This is basically to provide you flexibility. So there's two options. Response mode can be query or fragment. We are going to use fragment. But what this basically means is when the redirect happens, where does the code really reside? Is it in the hash fragment of the URL or the query fragment? Queries is something most people are aware of. That's why I'm using fragment. And when the redirect happens, I will spend some more time explaining these details to you. So this is basically the details of the app. Okay, these are details that can be easily exposed to the end user, and there's nothing confidential over here. Do note that there's no confidential information here because this is the HTML page. All of this code is visible to everyone. Next, what we're doing is I've written a small helper here, which is generate GUID, basically copied from this URL. This code is going to be available on a GitHub repository. The link is going to be in my slide deck. So just wait for it to come up. We are generating GUIDs basically for state and N1s. N1s is not really required right now. That's required for OpenID, but I've just placed it there. And what we are doing is we're generating a state, because state is something that we are going to use. Using the information above, we are generating this URL, which is login.microsoft online. It has the tenant ID. So this is important to understand. This tenant ID can be the Azure Active Directory tenant that you're using. But if your authorization flow, if your app supports Microsoft accounts also to log in that case, this can be something like common. Okay. So there are different variations over here. Again, Microsoft has decent documentation about it. In this case, we are only allowing organizational users. So it's going to be users from a particular organization for which we have used the tenant ID directly. So for every tenant ID or or if we are going for common for everyone, there's a specific endpoint. So if you are going for an organizational user only model, in that case, you have your own organization level endpoint, which is not used by anyone else. And then you are having the client ID, response type, all of those parameters are populated over here. Cool. So our redirect URL is going to be exactly this. So let's try this out in the browser. I'm going to quickly, I've been running some experiments. So this is open. So this is what the server looks like. We're going to look at auth flow and we're going to look at login. Let me clear this up. Now, for those online, I'm completely aware that the client ID and client secret as well is going to be exposed in this webinar. I'm going to be make sure that I'm deleting all the apps that I've created throughout this demo. So I hope you don't try to just sneak in and try these client secrets by yourself. Okay, so we are at the login page. We know the JavaScript code that is really powering this page. We're going to click on the login button and you see that it has navigated to this URL. Okay, what has happened is something happened too quickly. And it happened too quickly because I was already logged in. So what I'm going to do is I'm just going to quickly move to incognito. Should have thought of this. Okay. So I'm just going to show you by logging in once, then I'm going to go back out of incognito because for other flows, you can just assume that what the login flow looks like. But to make sure that we are going through it at least once, we're going to do that. Okay, so that's my org credential. I'm going to select org account. Okay, this is multi-factor authenticated, so I think there's going to be something. Yeah, so you see, this is the consent form that's being shown to me now. Yeah, so it's basically asking me that do I want to consent this. Now, the reason there's something interesting that has happened over here. It is saying me consent on behalf of your organization. The reason is that I am an admin and I can actually add this permission to Azure AD as well. So if I go back to Azure AD, under API permissions, the Cheers API permission is not present over here. So what we are basically going to try and do is just accept this. Okay, this worked, but there's no redirect URL registered. Let's just quickly go back over here and yeah. Do you see this? This showed up because I am an admin. I got that prompt. If I was not an admin, the prompt would have been that your administrator has not allowed this app to do so and so activities. But now this is permitted. What I'm going to do is just to make sure nothing breaks in our flow, I'm also going to officially add this over here. So it basically shows up granted under the permissions for Cheers web client. Okay. And what the error is in our case is no reply address is registered for the application. So we do have a redirect URL and that redirect URL is not already present over here. Now I've kept this open intentionally because this is important. The reason is that the redirect URL is a trusted endpoint being used by Microsoft to pass on sensitive information. So you have to be explicit about it. You have to make sure that you mention redirect URLs explicitly over here. Make sure you are not using wildcards in any ways. Some authorization servers support wildcards. But the risk over there is, if at all, you end up redirecting on a page that is vulnerable to some sort of a cross-site scripting attack due to user populated information, you run at the risk of your users' tokens being stolen or users' codes being stolen. So this auth flow could be hijacked over there. So we're going to be explicit over here. I'm going to say web, and I have added the redirect URL right here. It generally starts reflecting in a couple seconds. I've never seen delays, but I'm just going to be a bit cautious. Let's try and refresh. I don't think it's going to work with a refresh either. So let's go back to auth flow login, and let's make another attempt. Now this time I was already logged in, so it has not asked me to log in. And you see that the flow is complete. We already have the code over here with us. Okay. So what's in the URL? I've just written some JavaScript that shoots it into the console as well so that we can see it. So what we have received is, we have received a code, we have received a session state, and we have received a state. Now, session state is something that reflects the Azure AD STS state. Basically, if the user relogs in, the session state changes. Now, this is only important if you really care if your user has relogged in or not. Otherwise, this does not play a role in the OAuth flow. The state and the code, however, do. Okay. Now, what we are going to do is, this code will have to be exchanged, I suppose, within 15 minutes for a token. And to do that, we have written a PowerShell script. So let's go to PowerShell and let's take a look at the PowerShell script as well. So I have the same scope, same client ID present over here. This time I have the client secret too, because to exchange this code and get the access token, I'm going to need the client secret. So I'm going to paste the code right here. Oops, I had copied the whole JavaScript object apparently. Okay, copy message and okay, there is a way to not copy the whole thing. Yeah, that's the code. And we are quickly going to copy the state. Now, some authorization servers do enforce this to 3 minutes. But hopefully this is going to work for us. If it doesn't, we just make an attempt again. So let's just go to the correct directory and find get token, and we run this. And yeah, and now what we have received is, in turn of the code, we have received a token. Now you'll notice there's a secret over here. This is the reason why I'm using PowerShell and not the front end. The client secret is supposed to be confidential. We cannot store this client secret in the web app itself. Nowhere in your Angular or React.js, even if it is completely obfuscated. No way can this sit over there. This has to be on the back end. So what happens is, when your server receives that redirect with the code, this message reaches your server and your server can exchange this code for a token. Now, if you remember, I had mentioned about query and fragment in the response mode. If you notice here, this is not a question mark. This is a hash. It's a hash because I've said fragment. If I had said query, this would be a question mark. Okay. So it just depends on how you want to handle this in your application. Whatever fits your flow, you can configure it that way. That's basically the auth code flow that we see over here. This is what we have done right now. What I'm quickly going to do is, I'm going to copy this token and I'm going to paste this. Now I'm going to close incognito because I prefer to have fewer windows. So let's just go back here. And I have jwt.ms open. Now we are pasting a JWT token, an organization's JWT token, into a website that we do not own. So we have to be very cautious over here. There are a lot of JWT viewers out there, but be very cautious, especially developers have a habit of moving JWT tokens and entering them in your browser. You should be very cautious about it. JWT.ms is something that I relatively trust. That's why I'm using that, but I would still recommend that ensure that any tokens that you paste, if it's too sensitive, just avoid. Try and decode them locally using some native code. Okay, and this is either with the Azure tenant that I'm using right now. It's a test tenant. It's not my organization's tenant, so I can be a bit carefree over there. So this is what the token has. This is the information that the token contains right now. Now, this is one question that I would like to ask, that if I have this token, when the Cheers API app will receive this token as part of the request. So the client app is now going to use this token and send a request to the API, correct? Now we are not going to look into that because that's beyond the scope of today's session. But what I would like to know is, if you were building that API, what would you use from this token to really authorize your request? If you have the answers to this, just put them in the messages. I'm aware that the stream can be delayed for some people, so we're going to use that time and we're going to come to that come to those answers towards the end of this session. Okay. Now this is a JWT token. What I would like to still make clear is OAuth does not say that you have to use a JWT token. The access token can be anything. There are RFCs that support the JWT structure. For example, OpenID Connect. That's one of the proposals that says that you could use JWT tokens in there. But OAuth does not dictate that. So if you're building your own authorization server, you don't really have to have JWT in there. So if you're developing an application keeping OAuth in mind, you would have to make sure that the JWT decoding logic is decoupled from your OAuth implementation. Okay, because by contract, OAuth tokens could be anything. So even if you are using an authorization server like Microsoft's authorization server in this case, your clients especially should not be the ones who peek into the token thinking it's a JWT and start inspecting it. You are bound to break your flow because even Microsoft is not contractually obligated in this case to go ahead and to not go ahead and change it. So they could change it in some cases. They will not. I'll explain those details as well again why in this case. But if you're working with Graph API, for example, the tokens that are generated for Graph API, the way those tokens are decoded, it's controlled by Graph. So when it's controlled by Graph, if your clients are peeking into tokens that are created for Graph API, your flow is bound to break because Microsoft can just have custom access tokens being created for their own Graph API implementation. If you're building your own APIs on top of Azure AD, be assured that's again Microsoft is contractually obligated then to ensure that JWT tokens are respected because your APIs are going to decode that token. So it's important to understand this difference. Cloud Identity blog has an article about this topic around 3 years ago. While I was creating content for today's session, I came across that blog and I did find it really interesting that it's important to enforce these contracts on different levels for OAuth and maybe even OpenID Connect and so on. But this question is still open. What do you look at when you want to really authorize, when you want to know, can this token, can the bearer of this token uh, send a cheer or access the Cheers API? How do you know that? If no one answers, I will. No, don't worry about that. So let's go back to the slides. So this looks good. This auth flow looks good. And we are going to, I'm going to quickly peek for any questions coming in. Okay. No questions so far. That is great. So now, I do see someone has answered saying that scopes can be used. That's a good answer. Can you also name the attribute? That is this is Sachin Jagdale. So you say that scopes can be used. That's the correct answer. But what's the attribute in the JWT token that you would look at? Okay, so now what we are going to think about is, okay, but how will my JavaScript secure that secret? Like, yeah, we have seen that this client secret can be used to get the token. But what if I don't have a backend? What if I'm the developer for an app that just has a front end? It's just going to work with something like Graph API or some other APIs that are secured by Azure AD. How do I ensure that my secrets are secure then? Or should I even be having secrets? Okay. So this is the reason we have multiple flows. There can be different use cases. There can be different clients, different types of clients, different types of user experiences. And to support all of them, there are multiple flows. So we want to name the grant flows. Basically, there is the authorization code grant and there's the authorization code grant with PKCE. Microsoft today supports both of these, and it also supports implicit flow and password grant. But both of these are considered legacy. I'm not even going to talk about password grant today, but if you are interested, you can go ahead and read about the resource owner password credentials grant with Microsoft. I think people call it the ROPC as well, which is basically where you can actually get username and password and start making API calls. Uh, but again, that is not recommended. I have personally never come across in the last 10 years, never come across a use case where I would have to use that particular grant flow. However, there can be some very restrictive scenarios where people are required to do that, but you have to be very vigilant if you are having to do that. There have to be some very strict policies enforced. But that's beyond the scope for today's session. I do not recommend that. What we are going to look at is implicit flow. It's legacy, but it has been one of the most popular flows. And some of your applications that are still running in production might also be having implicit flow. It is being supported by Microsoft right now. So we're going to go through it. The reason being, we want to understand what are the issues over there. Okay, so let's go to the implicit flow. This is what the implicit flow looks like. So again, we have the same participants. We have login.microsoft.com, we have virtual chairs API, and we have virtualchairs.com, the web app or the client app. And again, we have the resource owner Sanket who would like to, who has the intent to consume service. And here, Sanket basically gets redirected to the authorization server. There is again the same consent flow. So up until here, everything remains the same. What changes over here is in the redirect, we are getting the access token directly. Okay. We're directly getting the access token because we don't want to use the client secret. If we get the code, we will have to use the client secret to get the access token. We don't want to use the client secret. This is just a front end application in JavaScript or could be a mobile application. So in that case, the access token is coming in directly. Some of you might have noticed the problem already, but we're still going to go through this flow. Okay. And that access token is being used to access resources. That's the way it works. So let's look at a demo for implicit flow as well. So I'm going to close this and I'm going to have the discipline to clear my screen every time so that we don't get confused by messages. We're going to look at the login page. The login page is very identical to the one that we have seen before. Okay. So we have the client ID, we have the tenant ID. We are again, the response mode is again set to fragment over here. We have the redirect URI set. Of course, the redirect URI has changed a little bit. So we'll go ahead and update this redirect URI in Azure AD. So we have the page open here under web. Again, we are going to add redirect URI and save. Okay. And we have the scope. Oh, the scope seems incorrect. That's graph. That will still work. We have the permissions for it, but that's not how we want to demo. So we're going to quickly update that scope. That's why I call it the sandbox, right? I've been tinkering with these properties a lot over the last few days, and I might have to reconfigure them sometimes. But again, I have a generate grid over here. and the state, I'm storing that state in the session storage. All of that is happening, and we are redirecting the user to the login page. So it's basically the same. We saw that up till the login page, even the implicit flow is basically the same. The only thing is the response type has changed to token. Previously we were asking for a code. Now we are asking for a token. Let's go to the login page here. So implicit flow, login. Sorry. Okay. So we are at the login page. We are going to click on login. It didn't ask me to log in because of course I'm already logged in and I have the access token for me over here. Okay. So this access token again. Just hold on a second. I'm checking a couple things that seem odd to me. I'm going to quickly refresh this page. Okay, so what I'm confused about is I'm supposed to provide this, enable this implicit grant right here, without which this token should not be visible, but somehow it is. It could be a stale state of the app that triggered it, but that setting is required for sure. I do see that the client ID over here is incorrect. I do see that the client ID, oh, so my server has been throwing out something from the cache. Okay, we're going to go back to login and we're going to disable this. Pardon me for this glitch. So yeah, my HTTP server has a nasty habit of caching everything. I need to fix that. But now we are going to check if, yeah, the client ID is reflecting correctly. So there's another app that has the implicit permissions enabled. Okay. I'm going to clear this page again and we'll give it another shot. Okay. So let's do this. Yeah. Now that it has reflected the correct app ID over here, if you see that the client ID is B311 again. So it's the correct one now. And it says unsupported response type. Okay. The token response type token is not enabled for the application. Why do you think Microsoft went out of its way and blocked this and demanded that this should be explicitly mentioned that allow access tokens for my application? Why do you think that happened? The reason is that if the access token is actually visible in the URL, it's actually not a secure way to provide an access token. This could actually end up in my browsing history. Some browsers take care of not storing hash fragments. That's the reason why the response mode is also provided, so that you pass some information in the hash fragment so that it's not stored in the browser history. Uh, so it's not a very secure way. It's something that is immediately visible up there on a user interface. There could be a browser extension that could just pick it up from there. That's the reason why Microsoft demands that you explicitly mention it. Now we have explicitly done that. What they're also saying now is this app has implicit grant settings enabled. If you're using any of these URIs in an SPA, you should migrate with MSAL, you should migrate URIs. What you're going to do is we're going to quickly try this out, enabled, and you're able to get this access token right here now. Okay, we're going to address the SPA warning bit later. So what Microsoft is exactly asking us to do and what's recommended. So that's basically how we get the access token using implicit flow. That clear? Okay. So with that, now we know, okay, implicit flow is not a secure way to handle this. How else do we, what's the solution? So basically, implicit flow is vulnerable to man-in-the-middle attacks such as redirect interception. In case browsers that store hash fragments in browser history, the token can be leaked. So PKCE, which is proof key code exchange, uses a cryptographically secured approach of obtaining the access token on client side. That's the reason why we have to move to PKCE. So how does PKCE handle this? Let's take a look. So authorization code grant with PKCE, the same participants again. We have the trust established. There's again the resource owner, again intent to consume the service. This time the redirect, something special happens during the redirect. During the redirect to the login page, what we do is we generate a code challenge. Okay. Now this code challenge works like a dynamic client secret. So you cannot store a client secret in the in your JavaScript. Okay. The reason for that is that the client secret is static. If that client secret gets used by someone else, they can start generating tokens. For that very reason, PKC implements this dynamic secret approach where every time you redirect to the login page, you generate a secret. This secret is owned by the client itself. Okay, so it's the state of the client. It's basically for that particular intent only. We are not supposed to use that same secret again ever. The secret is included. The user gets redirected to the login page. There's consent asked if necessary, and the user comes back. If the consent is already there, the user is directly redirected again to the app. Once it's redirected to the app, the URL has a code in it. That code can be exchanged for the access token using the code verifier. Okay. So there's two ways secrets can be passed. The dynamic secret that we're talking about, there's two ways it can be passed. It can be passed in plain text, or it can be cryptographically hashed using SHA-256. The hash mechanism is something that what we are going to take a look in the demo, so it will be a bit more clear. But what basically happens is you send a hash over here, and while getting the access token, you provide the actual secret that was used to generate the hash. So Microsoft knows, if you're aware about a little bit of cryptography, you know that hashing is a one-way operation. You cannot decode a hash back to its original state. So you basically take the secret, convert it into hash it out so that it cannot be anybody who has the hash cannot derive the secret from it. But when you are getting the access token, at that time you provide the secret that was used to generate the hash. So Microsoft can now generate a hash for that secret again, check if the previously sent hash matches, and if it matches, in that case, it will provide you the access token. And that access token can be used to call the API.virtualShares app. Okay, is that clear? So what we are going to do is take a look at the demo. Let's close this. Let's collapse this. And we are going to go to login. This is where a lot of interesting stuff is happening. Okay. So what we have done, you'll notice I did mention very boldly that I didn't want to use any frameworks or libraries, but well, this is a cryptographic hash. I'm not going to write that logic myself. I have used a library over here, crypto.js, that's embedded in the page. We have the tenant ID, client ID. We have the response type as code because this is the auth code flow. Okay, this is the auth code flow. But we are wrapping it up with PKC. So we are also providing something called the code challenge method. Okay, and there's other properties as well. I'll show them as we scroll below. This is the generate GUID, so we can just collapse this. Right, and there we log in. So during logging in, you'll see that I'm generating the code verifier. So there's some code that again, some good people have hosted a gist on GitHub, which generates the PKC secret. So basically it generates secrets like these, and these secrets are then hashed out and converted into this. Okay. So the logic is implemented over here. I have these functions inherited. There's a URL, and I'll provide this URL with in the GitHub repository as well, so you can take a look at it. So what we are doing is we are saying there's a property called code challenge method. This can be either plain or SHA 256. Plain means you are going to pass the secret itself to Microsoft while doing your redirect. But that's not a very secure approach. That still adds some layer of security because the secret is one-time use. So once you generate the access token, this secret cannot be used to generate any future access tokens unless specific new secrets are also leaked. It is one-time use, but there can still be risk of losing this secret uh, midway while your browser is doing that redirect. So that hash, basically SHA-256 hash, ensures that you are completely secured. Your secret actually remains only in the memory of your browser. So it could go and sit somewhere like the session storage, and once the redirect comes back, you can use the session storage to pick this up, pick the code verifier or the secret up again, and get the access token. We're going to take a look at the redirect page code a bit later, but this is what we are doing over here. So all the properties are present here: client ID, response type, redirect URI, scope, response mode, state is there, code challenge method, that's S256. Then there's code challenge, which is actually the challenge. So in this case, it's going to be the hash of the code verifier or the secret. So code verifier and secret mean the same thing. Okay, and we have just added in once as well if at all we plan to use OpenID in the scopes. That's basically it. So let's take a look at the login page. So let's go back over here. Let's go to PKC. Let's clear our screen. Okay, this one's already clear. So I am now going to be a bit cautious. I have to make sure that the client ID over here is correct. It does look correct to me. So this page should work fine. Okay, so let's click on login. The redirect URL is not yet added. So I'm going to quickly go back, take the redirect URI. Every folder has its own redirect URI, so I have to go through this exercise. And what I'm going to do is this time, while adding the platform, I'm going to respect this. So this has to be SPA. If this really has to work, this has to be a single page application. Okay, it's not going to work otherwise. So you're going to register this and configure. Once we do this, you will see your redirect URI is eligible for authorization code flow with PKC. If we would have added this redirect URI over here during the login page as well, we would receive a prompt saying that this is not going to work. Okay, so we now know that this redirect URI can be used for PKC. Perfect. Looks like we are in good shape. Let's just refresh this page because I'm used to it now. And let's log in. Yeah, a lot happened over here. A lot happened, but we are going to go through that. So there's the code that came in with the state and everything. So this is what the URL contains: the code, the session state, and the state. Session state is something we can ignore. State is something that we will use. Let's take a look at what did the redirect page do. Okay, this is the code for the redirect page. In the redirect page, you will see there's no secret over here. Okay, there's no client secret over here. While there is a secret, it's not a client secret. Okay, so we are quickly going to, I'm going to collapse all the unnecessary functions and take a look at over here. So what we did is in the web page, if we go to storage and if we go to session storage, you will notice that the login page stored the code verifier over here. Okay, so the code verifier was stored right over here, and that same code verifier was used further to get the access token itself. Okay, so we picked the code verifier, used the client ID, scope, redirect URI, grant type, code. That's basically where the code verifier was picked up, and we sent the request. And that's how, just on the client side, without any backend, we were able to get the access token in exchange for the code. This is brand new. Okay. And this is something that you should be migrating to. If you're using implicit flow, you should make it a priority to migrate to PKCE so that all your authorization flows are completely secure. Okay. So once again, I would like to highlight, I understand that some of this code can be a bit complicated, but this code is going to be made available on GitHub. I recommend that you take a look at it and feel free to get in touch with me, create an issue over there, or even contribute if you feel like, but you will get more clarity there. Mayur, if you're still online, do you think I've been clear so far? Okay, it could be that Mayur isn't online, which is fine. Okay, let's move on from PKCE. Okay, so now we are coming to the last bit. Okay, this is the uh, uh, last flow that we'll explore in detail. So how does virtual chairs work with Teams then? We had said initially that we would also like to send notifications to Teams. So how would we handle that? Now, that is something that the API will of course do. That is a request that the API would send to Teams saying that a chair has been created and notify Teams or send a message on behalf of that user uh, to uh, to the channel somewhere that, hey, I have sent a cheer to XYZ. I've sent a cheer to Mayur for supporting me with this whole session or something like that. So that sort of a message can be sent on behalf of me as well. Okay. So for that, we have the on behalf of flow if you want to do something like that. So what is going to happen over here is this flow starts off from where uh, the Cheers API receives the access token for send cheer. So when cheers.com, the client sends an access token to us, and that access token is received by the API. It can validate that token and carry out the cheer within the system. And now it wants to send that notification further using Graph API to Teams. What it can do is it can use that same token, which is basically addressed to that particular user. In this case, it was Sanket. So it was Sanket's specific token. That specific token can be used by api.virtualcheers.com to get a token on behalf of Sanket. Okay, to make a call to graph.microsoft.com. And we are going to see what that call looks like. So there's just one API call over here that we have to be attentive to, which looks like this. Okay, so uh, in this case, the scope is groups.read, but it could be anything, any graph API scope that you want. The grant type has to be so and so, the client ID, of course, the secret. So this is the client ID and secret of the API. If you remember the credentials that we created early on, these are the credentials for the Cheers API. Okay, we are going to take a look at that AD app again. So these, and then there's the assertion. In the assertion, we are going to send the token that was sent by the token that was Sanket's token that was sent to us by the Cheers client app. Okay. So we have the scope and the requested token uses on behalf of. This is what we are going to do. So let's take a look. What I'm going to try and do is I'm going to try and use the same token that we have generated in the PKCE flow. Okay, which ends right here. And we are going to go back, and in on behalf of, I have a PowerShell script, which allows me to paste a token right here. And I have everything else set here. I have the grant type. I have Microsoft Graph. I'm not using the Teams scope. I've just added .default. If you're aware, .default basically allows me to get all the scopes that are basically provided to this app. And in this case, it is going to be Microsoft.user.read. So we have the client ID. Let's verify the client ID. It's always good to verify the client ID. Okay, we went two back. Okay, app registration, and we are going to look at this. So this is the same client ID that we have, and it's the same app secret that we have over here. Okay, right here. So let's quickly run this before the token expires. The token expires for 1 hour, so I'm not too worried. But let's hope that it works the way we want it to. Demo gods can go mad any moment. Yeah. And it says something along the lines. It should contain assertion. We do have assertion in there. Something was not saved. Okay. Okay, sorry, I did not save the PowerShell file. Yeah, so I have generated the JWT token over here. And now if you have noticed, the resource owner, which was Sanket, the user, does not have any idea that the Teams API token is being taken on his behalf. Okay. But if you see over here, we have the Cheers API, we have the whole token created, which is targeted towards graph.microsoft.com. Okay. We have user.read over here, profile, OpenID, email, all of those details. Cool. Got it? I So that's basically what the on behalf of flow, or some people like to call it the obo flow. That's what it looks like. Now it's interesting to note uh, the expires in number is a bit odd over here, right? It's 3154. And every time I run this, it's going to be lesser and lesser. Reason being, the expiry is always going to be the same as the expiry of this particular token, which is the way it should be. Okay. Now, some of you might wonder why, and we'll try to address that in the next couple slides as well before we conclude. Okay, so that is all with the flows. So any questions so far with any of the flows we have gone through? Okay, so I do have questions on the screen right now. Uh, and I do have the answer as well. So Sachin Jagdai has answered it very correctly. The question that I had asked, that which is the attribute in the JWT token that you would look at for the scope? Yes, if it is a JWT token for the user, it would be SCP. We are going to quickly take a look at that then, because we have it open. We did go through this scope as well. So SCP is the one that what we are going to look at. Okay. And then there is a question by Anonymous. What would be the most secured flow among all, and why? It is definitely the auth code flow. If you're using the backend as well, if you want to use client secret, it's the auth code flow. If it is a front end, it is PKCE without doubt. Okay. So if you do have a backend where you can store client secrets, that would be the most secure flow, because then in that case, your not even your temporary secret is exposed anywhere. Okay. But if you don't have a backend, if it is a front end application like a mobile application, PKCE is the way to go. Then we have a client ID, tenant ID to check if token is meant to be for that resource server. I'm not sure. Maybe this was an answer for some of the question I asked, but okay. Okay, so that's basically, those are all the questions that I'm seeing right now. I'm just trying to see if there's anything else that has come up. Okay, doesn't look like it. Okay, let's go back to the slide deck. Okay, so we saw, okay, how the tokens are being generated, but how do resource servers authorize operations? When I, as a resource server, receive a token, how do I know that this token allows this user to do XYZ or even log into my application? One thing that you need to be clear is tokens does not mean that you have access. You have to inspect the token. You have to really validate the token to understand uh, if the authorization applies in this case. So there's two ways. If you get a token, if it is not a JWT being sent to you, if it is just some ad hoc token, Authorization servers can expose token introspection endpoints. What these token introspection endpoints do is they allow resource servers to send tokens to the authorization server and ask the authorization server that, hey, do you think this token is valid? Because I cannot read it. I do not understand what this token is. Can you tell me if this is valid? And if it is valid, then I will allow this user to do so and so. But if you can imagine in an application with very high traffic, there can be a lot of chatter between the resource server and authorization server every time a new token is provided. So it's not a very scalable approach to rely on the authorization server to validate every token. In which case we go for self-encoded tokens. In that, yeah, and JWT is one of the ways of doing self-encoding. And uh, developers are actually open to innovate on how self-encoded tokens would work if you're building your own authorization server. But if you're working with Azure AD, we are going for the self-encoded tokens with JWT. So in that case, what we do is we validate token authenticity. We still have to validate if this token is really sent by Azure AD, because if we go to this particular page, this is text that I could generate by myself, right? So if you are not, if the resource server is not going to call Azure AD, how is it going to know that all of these strings are correct? How do I know that as a resource server, how do I remain assured that someone is not playing with me and just sending me a random information in here, very smartly populating the STP field and so on. And for that very reason, we use cryptography in our in the JWT tokens, and the JWT tokens are basically signed by keys that Microsoft maintains by itself. And I have a page open that might give you an idea of what those keys look like. Go to this URL. I wonder where it opens. Yeah. So this is the URL where the keys are generated. So what Microsoft does is it recycles keys continuously, and the public keys are available over here. So whenever you get a JWT token, you can basically go to this endpoint and validate the signature on that JWT token. Make sure that the JWT token has a signature, basically something that is signed by one of these public keys. So it's basically public key, private key cryptography. So the Microsoft's private keys are used to sign the JWT token, and these are the public keys. So any of these keys could be used. Of course, Microsoft is not going to keep a single key. It's always a good practice to recycle your keys, especially when you're when you're developing a very exposed service where your signatures are going to fly around. So if you feel that something is compromised, you quickly roll back to a different key. Okay, so that's basically validate token authenticity. You validate the audience. You make sure that the audience is you. Otherwise, I could just create an app myself, assign permissions to it, generate a token for it with similar scopes and just send it through to you. So you have to make sure that the audience is correct. So my graph.microsoft.com always checks that the AUD field is set correctly. If this is wrong, you will get the incorrect audience or invalid audience message. Okay. Then you want to validate the tenant as well. You want to make sure that this token was generated within your tenant. You could use the ISS field for that, which has the whole STS endpoint with the tenant ID. You could then validate scopes or roles. Why I say scopes or roles is there's one more flow that I have in my demo. I think we have time for it. We have 15 minutes. So I'm going to quickly do that. One of the easiest flows has been the client credential flow. Yeah. So this is basically a token that is going to be generated for the app. So I'm going to show you some difference over here, and it's important as a developer to know the difference of these. Let's go to number 5 and your token. Yeah. So we have generated a token using client ID, client secret. This is the client credential flow. Basically, if you have a web app, that wants to do things by itself, this is what you would use. So you're not using the identity, you're not using delegated permissions, you're using your own permissions. So we are going to quickly take a look at this. Um, I want to duplicate this page because I would like to keep that JWT token right there. And you see this. So over here, you see there's rules. Because this is a token for an app, okay, the ID type is app. This is what indicates what type of token this is. If the ID type is app, you want to check if this is a rule. So if you have APIs that can be used by end users and applications alike, you want to make sure you check the ID type. If the ID type is app, check for roles. If the ID type is the ID type over here, if the ID type is user, you check the SCP. Okay. So that's basically it. Now, again, this is not an exhaustive list. I would recommend you to go ahead and read the access tokens piece that Microsoft has. There's a lot of information over here, including the ones that have points that I've mentioned. You can use this to make sure you validate your tokens correctly. Now, Microsoft recommends using MSAL. I recommend that too. But these are things that you should be knowing whenever you are working, even if you're working with MSAL, even if all of this is abstracted away from you, you have to make sure that you're aware of these intricacies if you want to build a secure application. Because being overlooking any of these points could lead to an insecure auth flow. Okay. So with that, we are going to conclude our session today. I'm pushing some important links on the screen. um, the first link is the OAuth 2.0 RFC. OAuth 3.0 is being prepared for release, by the way. But OAuth 2.0 is going to be around still for quite some time. So if you would like to read the RFC, the real document, the holy grail for RFC of the OAuth 2.0, go ahead and read it up. It's 6749. PKCE was an extension from OAuth 2.0. OAuth 2.0 originally did not have PKCE. It was a recent addition, which can be found over there as well. So that's RFC 7636. And then I would also encourage you to read OpenID Connect. A lot of times concepts between OpenID Connect and OAuth 2.0 are mixed. So if you go ahead and read up OpenID Connect, you'll also identify that OpenID Connect adds the identity layer on top of OAuth, allowing you to understand what the identity of the user is within the OAuth flow itself. So you'll get some more clarity over there. I really encourage you to go ahead and visit that. So yeah, that's basically it. I think that's all for today. If there are any questions, we'll wait for a couple minutes for questions, or else we will move towards conclusion. That's basically my last slide.
That was a perfect photograph for questions, Omya.
Oh yeah, let me bring that up again. Yeah, that's a that's a cute puppy. I like dogs.
Yeah, that's beautiful. Okay. By the way, we should. I forgot to announce it last time, but if suppose people log in with their actual name and email ID, and if they ask questions, we can give away some licenses.
Right.
So
So
yeah, go
if
ahead.
you have some goodies today, Mayur, you could set an example. Sachin Jagdaye has been answering questions, so maybe
Okay,
he's a
perfect,
candidate if at all there are
perfect.
goodies. Yeah.
Yeah, I guess let me just quickly check. I guess I have a license. So, Sachin, can you just send me an email on tendulkar@outlook.com, or probably I will reach out to you
Or
on.
Sachin could drop his email over here, and we could get in touch with him.
Yeah, just drop me your email ID as a question, so I will have access to that. Uh, so let me just quickly check.
Yeah, the stream might be a bit delayed, and let's use that time for questions. So if there's any questions, we can
Okay,
address that.
I will share it by next month. Okay, so if there are no questions, probably we can You can
Yep.
conclude.
Yes.
Thanks a lot.
So before we close off, my blog is up here. There'll be a blog about today's session as well. I've been making a habit of converting all my sessions into blogs as well. The repository, the code that we saw today, the sandbox code, it's not there in this repository right now, not complete, but by tomorrow morning it will be there. So if you're watching this today, go ahead and star or fork this repo and make sure you're updated with new changes. What I'm doing is whatever experiments I do with Azure AD, I'm trying to curate all of them over there. One of the samples from my previous session is already in there from enterprise integrations with Azure serverless. So yeah, just go ahead and do that if you feel like you'll be using that OAuth sandbox. So yeah, with that, I'll conclude my session. So thanks Mayur and Mahesh for helping me out here. With that,
Welcome, mate, and thanks for presenting at POJ. Appreciate your support.
great. Thank
So,
you. Have a good
okay,
weekend,
so
everyone. Bye
have a
bye.
good weekend. Bye bye.